Hello again, dear friends. I hope you're all doing well. Last lecture we talked about derivatives. What is a derivative? What do we mean by a derivative? Uh, we um, we talked about slope. In general, we said if we say find the slope of a function, what does that mean? That means find the derivative of a function. Okay, and it was the same meaning as finding the rate of change. Okay, rate of change. So we had three notions giving the same meaning: slope, derivative, and rate of change. In general, we talked about some rules of differentiation. We had a constant function. The first rule that we had, it was about if you have got a function that's a constant number, how do you find the derivative of this one? The derivative is equal to 0. If you have got a power function, for example, f is equal to x to the power of n, how do you find the derivative of that function? F prime is equal to, we said that n comes in front of the x, nx, and then that power of the x decreases by 1. So it becomes x to the power of n minus 1. Then we studied what? We studied the sum rule. If I have got two functions added together and I want to take the derivative of them, how shall I find this one? I will simply find the derivative of f plus derivative of g. Okay, and if I have got subtraction, that addition will change to subtraction. Then we had the multiplication of two functions. If I have got f that is multiplied to g and I want to take the derivative of those together, how can I find this one? We said that's equal to the derivative of f multiplied to g, okay, plus the derivative of g multiplied with f without any change. Then we had the derivative of quotient. That means a function divided by another function. How do you find the derivative of this one? That's equal to the derivative of f multiplied to g minus, here we have got minus, the derivative of g multiplied to f without any change all over the denominator squared. Whatever I have got for g, that will be g squared. These were the rules that we got from the last lecture. We also had a higher order differentiation. In higher order differentiation, we had second and higher order differentiation. When we were talking about second and higher order differentiation, it was again the same differentiation, but instead of taking one time the derivative of the function, we were taking the derivative of the function two times or higher. Okay, so if I have got a function, for example, f that's equal to x to the power of 5, and it is required from you to find f triple dash of x, how do we find it? We are simply finding the first derivative of the function, that's equal to 5x to the power of 4. Then we will find the second derivative because the third derivative is required from us. So we have to find the first derivative and the second derivative of the function so that we can find the third one. So what is the second derivative of that function? The 4 comes in front and that will be 20x to the power of 3. And then for finding the third derivative of the function, we have to find the derivative of the second derivative. 3 multiplied to 20, that is 60x squared. So that is the third derivative of that function. Okay, now we are coming to the derivatives of trigonometric functions. What do we mean by trigonometric functions? You already know that we have got 6 trigonometric functions. Let us give a quick review for the trigonometric functions. Trigonometric functions. We've got 6 trigonometric functions. The first one is sine, okay, sine of x, and then we have got cosine of x, then we have got tan of x, that's tangent of x, that's equal to what? it is equal to sine x over cosine of x. Then we have got cotan of x, cotangent of x, that's equal to cosine of x over sine of x. We have got secant of x, that's equal to 1 over cosine of x. And the last one, we have got cosecant of x, that's equal to 1 over sine of x. So these ones are the 6 trigonometric functions: sine, cosine, tan, cotan, secant, and cosecant. We already know them. We have already talked about their domains and ranges, the points where they are undefined. Today we are going to talk about their derivatives. The first function that we have got is the sine function. Okay. What is the derivative of sine function? If I have got f of x, that's equal to sine of x. To find the derivative of this one, that's simply equal to f of x. F prime of x is equal to cosine of x. So in general, when we have got the first trigonometric function sine of x, and it is required from you to find the first derivative, you have got sine of x, the derivative of it is equal to cosine of x. In the lecture notes, that derivation, the derivative of sine, is found by the method of definition, finding the limit of that one. But it is not required from you to do the proof of that. So it is just required from you to know that the derivative of sine of x is equal to cosine of x. The first example that we have got, example 1, in the lecture notes, it says find the derivatives of the following functions. The first function that is given to us, y is equal to x squared minus sine of x. What's required from us? It says find the derivatives of the followings. Okay, the first function that is given to us, as I said, it is y equal to x squared minus sine of x. So to find the derivative of this one, this is the subtraction of two functions. So we are simply finding the derivative of this one minus the derivative of that one. So y prime is equal to what? Derivative of x squared is 2x. We have got the minus sign in here. And what is the derivative of sine x? That is simply equal to cosine of x. Okay, the second example, second part, y is equal to x squared multiplied to sine of x. If you look at this one, there is subtraction between the two functions. The sum rule is used in here. But here we have got the multiplication of x squared with sine of x. So we have to use product rule. What is product rule? If we know that if you have got f multiplied to g and found the derivative of this one, it becomes first one's derivative multiplied with the second one plus the second one's derivative times multiplied with the f. So to find the derivative of this one, y prime is equal to what? First one's derivative, that means the derivative of f, the first function. What is the derivative of this one? That is 2x, okay, multiplied with the function g without any change. That's the function g, so we are multiplying it without any change. I can write this one is the f and that one is the g that we have got from here. Okay, and then I have got addition, so I will put a positive sign here. The derivative of g, what is the derivative of sine? That is cosine of x multiplied with f without any change, so that one is x squared. Rearranging that one, so y prime is equal to 2x sine of x plus x squared cosine of x. And that's the derivative of that given function. The third one, we have got same y is equal to sine of x over x. What do I have? I have got that function f, and I have got that function g. So f is divided by g. How do you find f divided by g, the derivative of this one? It is the derivative of f multiplied with g minus the derivative of g multiplied with f all over g squared. So let's find that derivation. Y prime is equal to what? F prime. So the derivative of sine x is equal to what? Let me first do the bar. That's equal to cosine of x multiplied with g without any change, so that is x. Okay, then I have got minus the derivative of g is equal to what? Is equal to 1 multiplied with f without any change, so that is sine of x all over g squared. G squared is simply x squared. Let's rearrange this one again. Y prime is equal to x cosine of x minus sine of x all over x squared. And that is the derivative of that given function. So what have we studied? We have studied the derivative of sine function. Now we are coming to the derivative of cosine function. Okay. What is the derivative of cosine function? F of x, if it is given to you, that's equal to cosine of x. So f prime of x is equal to what? Is equal to minus sine of x. Let's do some examples on cosine also. The second example that we have got, example 2 from the lecture notes. Again, it says find the derivatives of the followings. What do we have? The first one, we have got y is equal to 5x plus cosine of x. How do you find the derivative of this one? Simply, this is addition between them. So y prime is equal to, the derivative of this one is 5, and the derivative of cosine function is equal to what? Minus sine of x. So that will be minus sine of x. And that's it. Next, what do we have? We have got y is equal to sine x multiplied with cosine of x. That's what? That's multiplication between two functions. The function f is the sine one, and the function g is cosine. When we have got multiplication between two functions, so again, what do we have? First one's derivative. What is the derivative of sine? That is cosine of x multiplied with the second one without any change. So it is cosine of x. Okay, first one is derivative multiplied with the second one plus second one is derivative. What is the derivative of cosine? That is minus sine of x multiplied with the first one without any change. So that is sine of x. So this one is equal to what? If we rearrange and simplify this one, that's equal to cosine squared of x minus, okay, because that minus is multiplied with that, plus sine squared of x. And that is the result. Let's move to the third one. See, y is equal to what? Cosine of x over 1 minus sine of x. How do you find the derivative of this one? That is the division quotient rule. So we have got that one is the f function over the function g. If you have got the quotient function, what can we do? We say that first one's derivative, let me first draw the bar. First one's derivative, what's the derivative of cosine? That is minus sine of x multiplied with g without any change, so that one is 1 minus sine of x minus, okay, from the rule we have got a minus. Second one's derivative, I mean the derivative of g. What is the derivative of this one? The derivative of this is 0 minus the derivative of sine is cosine of x multiplied with f. What is f? Cosine of x all over the denominator squared, 1 minus sine x all squared. Let's do the simplification. So y prime is equal to, this one is multiplied to inside for this one and for that one, so it will equal to minus sine of x multiplied to 1, that is minus sine of x, minus sine x multiplied to minus sine x becomes plus sine squared of x, okay, minus multiplied with minus becomes plus, cosine multiplied with cosine is equal to cosine squared of x all over 1 minus sine of x all squared. Okay, here we have got sine squared of x, cosine squared of x, that bit. We have got a rule, sine squared of x plus cosine squared of x is equal to 1. So this one changed to what? Y prime is equal to, I have got 1 minus sine of x all over 1 minus sine of x all squared. Okay, here I have got 1 minus sine x, 1 minus sine x, the power of this one is 1, the power of this one is 2, so they cancel each other. So y prime is equal to what? Is equal to 1 over, this one cancels with the numerator, 1 minus sine of x remains, and that will be the result. Page 9. Okay, that was the derivative of cosine function. So what have we studied so far? We have studied the derivative of sine function, that's equal to cosine. Okay, the derivative of sine function is equal to cosine, and we've studied the derivative of cosine function, that's equal to minus sine of x. Now we are coming to the other trigonometric functions. We will study the other trigonometric functions and find their derivatives. We have got the other four trigonometric functions. The other one is, if I have got the function f of x, that's equal to tan of x. What is the derivative of tan? F prime of x is equal to secant squared of x. If I have got cotan function, cotan of x, that's the function I have got. What is the derivative of this one? F prime of x, that's equal to minus cosecant squared of x. Okay, tan, the derivative of it is secant squared of x, and the cotan function, the derivative of it is minus cosecant squared of x. I have got two other trigonometric functions. If I have got f of x, that's equal to secant of x, the derivative of secant function is what? Is equal to secant x tan x multiplied together, and I have got the last trigonometric function. If I have got f of x, that's equal to cosecant of x. F prime is equal to what? Is equal to minus cosecant of x cotan of x. Okay, these ones are multiplied together. Of course, it doesn't make a difference if the minus is with the cosecant or with the cotan, but in general we are just writing it in front of this. We've got an example 5. It says find again the derivative of tan of x, but this one is the Example 5 is the derivation of the derivative. I mean, like to find the derivative of the 10x in a derivation way, but it is not required from you to see how this derivation is found. So just leave that example, okay, skip it. We have got example 6, okay, we are moving to example 6. Example 6, it is required from you to find y double prime, that is the second derivative of the function y is equal to second of x. So what is given to us? Second function is given to us, and it is required from you to find the second derivative of second function. Okay, how do you find the second derivative? Of course, if you want to find the second derivative of the function, first you have to find the first derivative of the function. What is the first derivative of second function? That's equal to second of x multiplied with tan of x. It is required from you to find the second derivative of the function. Since it is required from you to find the second derivative, so this is the multiplication of two functions, f and g again. So we have to find it in the product way, product rule, using product rule. So this one becomes first one's derivative, that means the derivative of f. What is the derivative of f? Second function, that is second x tan x multiplied with g, that is tan x, plus the derivative of g. What is the derivative of tan? That is second squared of x multiplied with the first one, okay, second of x. So what did we do here? I have got the first derivative of second x equal to second x tan x. Then it is required from us to find the second derivative. How do I find the second derivative? I'm finding the derivative of the first derivative. The first derivative is given to me, that's equal to second and tan. This is the multiplication of two functions, so we are using product rule. Product rule says it equals to f prime, okay, multiplied to g, that is g, and that is f prime, the derivative of f, plus the derivative of g multiplied with f. If you look here, we get this one. Let's do some simplification, arrangements and simplifications. I have got second x tan x multiplied with tan x, so that one will equal to second x tan squared of x, plus here I have got second to the power of 3 of x, and that is the required result. In example 6, a limit is given to us. To be honest, it's not related with the differentiation that we are studying right now, okay? It is required from you to find the limit of x approaching to 0, okay, of the function 2 plus second of x over cosine of pi minus tan of x. As I told you, it's not related with the differentiation, but it is just an example of limits given to us. You know how to calculate limits. If a limit is given to you approaching a number, if that number is not making a problem for you, you're directly inputting it into the function that we have got. So let's put 0 in second function. What does that equal to? If I put the limit into here, second of 0 is equal to what? I will get, let me write it down like that, 2 plus second of 0, because 0 in second function doesn't make a problem for me. That's why I'm directly inputting it inside the function, over cosine of pi minus tan of 0. Again, tan of 0 is not making a problem for me, so I'm directly inputting it. Second of 0 is equal to what? As we know, second is equal to 1 over cosine. So that will be cosine of 0. Cosine of 0 is equal to what? Cosine of 0 is equal to 1. So that one will be 1 over 1, and that's all equal to 1. So I get from here that limit is equal to 2 plus 1, okay? Because secant of 0 is equal to 1. Let's do the other one. Cosine of pi minus tan function is equal to what? I know that tan is equal to sine over cosine. Sine of 0 is equal to 0, cosine of 1 is equal to 1, so the result is 0. So that one will equal to this. Let me simplify it more for you, although I do not need to do that. That will equal to cosine of pi. Cosine of pi is equal to what? If you remember, that's 2 plus 1, okay? Cosine of pi is equal to minus 1. So the result is what? That is 2 plus 1 is equal to root of 3. And I have got a negative sign in here, so that one is equal to minus root of 3, and that is the result. Okay, so far we have studied the derivatives of the 6 trigonometric functions. We know how to deal with them. If you just know the derivatives of them, you can do any differentiation, you can do any derivative, and it is, I think, easy. Let's move to the chain rule. What is chain rule? In chain rule, I have given a function inside another function, okay? For example, if I have got, let me write the chain rule here. Or we can say when we are taking the derivative outside inside rule. When we are using chain rule, we are calling it sometimes in some places it's called outside inside rule. Okay, how is that function given to us? In general, when we were finding differentiation, derivatives of functions, for example, f was given to us, that's equal to x to the power of 3. How do I find the derivative of this one? F prime is equal to, simply that's equal to 3x squared. How about if the function is given to me like that? F is equal to, for example, 3x to the power of 3 plus x squared all to the power of 3. Look, I have got here x to the power of 3, but now here I have got what? I have got this function to the power of 3. Okay, so a function is put into another function. Or in general, we say that it's a composition function. If you remember, composition function. What's a composition function if you remember? That is f circle g or g circle f, doesn't make a difference. The important here is that we know that it's a composition function. A function is put into another function, okay? So here, instead of x to the power of 3, I have got that much to the power of 3. How do I find the derivative of this one? We are using chain rule, but I'm not going into the depth of this subject. I'm just showing you the rule. Okay, f prime, if you look at this one, x to the power of 3 becomes 3x squared. So the same thing I will do. I will say that it's equal to 3, that bit squared, okay? 3, that bit all squared, okay? Because this one is considered instead of the x. 3 squared, and instead of the x, I have got that bit. But when I have got a composition function, I have to do something else also. What is that thing? I have to multiply that derivative by what? By the derivative of inside. Okay, the derivative of inside. I'm taking that derivative. So what's that derivative? The derivative of inside, that's equal to 9x squared plus 2x. Okay, so that one is called the chain rule, finding the derivative of a composition function, or we can call it as outside inside rule. So what do we have here? We have got, instead of a simple function, we have got a function composed with another function. Okay, how do you find that derivative? We are simply using the rules of differentiation, but we are adding also a bit. Okay, we are multiplying that derivative that we found with the derivative of inside. Okay, The derivative of inside is equal to what? 3 multiplied to 3 is 9. That one is decreased by 1, it's x squared, plus the derivative of this one is equal to 2x. Okay, let's move to the examples that are given in the lecture notes. It says the first example that we have got, it says find the derivative of the function y is equal to 3x squared plus 1 all squared. How do I find the derivative of this one? Y prime is equal to, if you look at this one, you can consider that function as y is equal to what? X squared. But instead of x, what do I have? I have got that whole function. That one is composed inside it. So how do I find this one? The derivative of this one is 2x. So the derivative of this one is equal to 2 that bit. Okay, 2 3x squared plus 1. But since I have got instead of x something else, so I have to multiply it with something else also. Okay, it's not done yet. Finding the derivative of that bit right next to it. What's the derivative of inside the bracket? It's equal to 6x. Rearranging this one, what will we get? We will get 6x multiplied to 2, that's equal to 12x multiplied to 3x squared plus 1, and that is called the differentiation of chain rule or outside inside rule. You can simplify it more multiplying this one to here, but doesn't need to. We do not need to. Okay, let's move to another example. Example 2. Again, it says what? Find the derivative of y that's equal to cosine of t squared plus 1. The function that is given to us is cosine of t squared plus 1. How do you find the derivative of this one? Let's write y prime is equal to, if I have got cosine of t, okay, if I have got y is equal to cosine of t, what is the derivative of this one? Y prime is equal to minus sine of t. But instead of t, what do I have? I have got this bit, so the derivative of this one is equal to minus cosine of that bit, okay, minus sine of t squared plus 1. What do I have to do more? It's not done yet. I have to multiply it to the derivative of inside. What is the derivative of inside? The derivative of this, it is 2t. Rearranging this one, minus multiplied to that is equal to minus 2t sine of t squared plus 1, and that is the result. Okay, so when you have got a composition function, you're not just leaving it like that. You also have to do what? Multiplication by the derivative of the inside. We are given another example. Example, I think 3. Again, find the derivative, okay, the derivative of the function y that's equal to sine of x squared plus x. How do you find the derivative of this one? We know that the derivative of sine is equal to cosine, so y prime is equal to cosine of x squared plus x. But since it is not a simple function, it's not just x, so what do we have to do? We have to also multiply it by the derivative of the inside of the bracket. What is the derivative of that bit? It's equal to 2x plus 1. So rearranging this one, that's equal to 2x plus 1 multiplied to cosine of x squared plus x. Even if you leave it like that, it's fine, but rearranging it will make it nicer. We are given another example, although that would be lots of examples, but it is fine. Hope you will understand them. Hope you will have no problem with my explanation. And of course, as I have told you, you can ask me questions online, sending emails, or contact me however you want. Okay, let's move to the example that is given to us. Example 4. Again, it is required from us to find the derivative of the function y that's equal to tan of 5 minus sine of 2t. Okay, let's find the derivative of this one. Y prime is equal to what? What is the derivative of tan of x? It is equal to, the derivative of tan is equal to secant squared of x. Okay, so that one is equal to secant squared of, instead of x we have got that much, 5 minus sine of 2t. Since it's not a simple function, so we also have to multiply it by the derivative of inside that bracket, the angle. What is the derivative of that bit? The derivative of 5 is 0. The derivative of minus sine of 2t is equal to what? Minus cosine of 2t. But since, again, instead of x, instead of the angle x, we have got 2t, so we have to also multiply this one by what? By the derivative of this one, that is 2. Okay? So the derivative of tan is equal to secant square of that one. The derivative of that one is equal to minus cosine of 2t multiplied with the derivative of the angle. If you want, you can rearrange this one again. I have got minus 2, okay, minus 2 cosine of 2t, all multiplied with secant squared of 5 minus sine of 2t. And that is it for that example. We have got example 5. Again, of course, it's required from you to find the derivative of the function of, I think, 3 functions are given to us. 3 functions are given to us. So the first one, it says find the derivative of y, that's equal to 5x to the power of 3 minus x to the power of 4, all to the power of 7. What is the derivative of this one? We know that if you have got y that's equal to x to the power of 7, what is y prime? That's equal to 7x to the power of 6. But here, instead of x, what do I have? I have got this one. So y prime is equal to 7 5x to the power of 3 minus x to the power of 4, all to the power of what? 6. Because instead of x, of that x, I have got this one. So this one all to the power of x. And then, since it's not a simple function, so I have to multiply it with what? The derivative of inside. What is the derivative of inside? That's equal to 15x squared minus 4x to the power of 3. And leave it like that. Or you can multiply 7 with this one, 7 with that one, and you will get the simplified form. Part B, we have got y is equal to 1 over 3x minus 2. I can rearrange this one. Instead of saying this one is the function f, that one is the function g, and I will use the quotient rule, you can simply change this one to 3x minus 2 to the power of minus 1. That will be simpler and easier to calculate its derivative, to find its derivative. So what is y prime? Y prime is equal to minus 1, okay, because minus 1 comes in front. 3x minus 2 to the power of what? Power of minus 2. It's decreased by 1. And then multiply it with the derivative of inside. What's the derivative of inside? That's equal to 3. Okay, derivative of this one is equal to 3, derivative of minus 2 is equal to 0. Rearrange, simplify this one, minus 1 multiplied to this, that will be minus 3. 3x minus 2 to the power of minus 2, and you can bring this one to down and do this one also.